Welcome, everyone. We are just about finishing up the unit. So today I'm going to do about 4 problems. The first 2 are going to be a little bit more review from what we've done previously in the unit, and then the last 2 are going to be things that we really haven't seen before this year. So let's start off with a little bit of review. Just simple solving for x here in this equation, where I have 2x minus 7 in the numerator and then 3 in the denominator. And I'm trying to isolate x. Remember, x is the introvert that likes to be alone. So I see that I have everything in the numerator here, this 2x minus 7, all of that is being divided by 3. So usually I don't really like fractions, right? They kind of get really messy as we work through problems. So I want to get rid of this fraction. So since this entire left side over here is being divided by 3, what I'm going to do is I'm going to go ahead and multiply this left side by 3. And then, of course, I'll multiply the right side by 3. And when I do this, and maybe it helps if I draw a line down the middle. When I do this, I see that on the left side over here, I have a 3 multiplying to everything in the numerator. But then I'm also dividing by 3, right? So I'm multiplying by 3 and I'm dividing by 3. Well, those are inverse operations, right? So these two actually reduce out. My 3 is reduced. They cancel, as we sometimes say. And that just leaves me with 2x minus 7 equals 5 times 3 is 15. Okay, and now this problem all of a sudden looks much easier to work with. Right, so I have a 2 times x here and a minus 7. Usually what I like to do whenever I'm solving equations, and this works 99% of the time, I'm going to kind of contradict myself with what I just did, but usually I work in the reverse order of operations. Right? So usually when I'm solving equations, I kind of start at the bottom and I work my way up. So that kind of doesn't make sense in the first equation that we did. Sometimes when we're dividing everything by something in the denominator, that kind of reverses this strategy over here. But after I multiply by 3, well, now I just kind of work in the reverse order of operations. So I do my addition and subtraction first. Right, so I'm going to move this minus 7 to the other side by simply adding 7. And when I add 7 to both sides, I'll get 2x equals, that gets me 22. Okay. And then after addition and subtraction, I have multiplication and division. So this is 2 times x here, and to undo the multiplication, I'm going to divide by 2. And I see that x equals 22 divided by 2 is 11. Okay, so I understand that what I said over here about going in reverse order of operations doesn't always hold true, right? I mean, obviously I didn't do the exact thing in the very beginning of the problem. But it's just whenever I'm dividing an entire side by a number, that can kind of get really messy, so I try to get rid of that denominator right off the bat, right? And in this case, it was by multiplying by 3 to both sides. Let's try another similar problem. This one's a little bit different. So here I have h divided by 4 plus 3 equals 8. And I'm trying to get h by itself, right? Because now h is the introvert that wants to be left alone. And so I have this division here and I have this addition. Let's worry about this addition first, right? Let's go ahead and subtract 3. Get that 3 to the other side. And that leaves me with h divided by 4 equals 8 minus 3 is 5. And then I have h divided by 4, so I'm trying to get rid of that 4, and I'm thinking, what's the opposite of division? Well, multiplication. So let's multiply by 4. So on the left side, I have my 4, I'm multiplying by 4, and I'm dividing by 4. So these two reduce out, they cancel. And that leaves me with h equals 5 times 4 is 20. So these first two problems were a little bit of review. I'm sure that every one of you could have solved them by yourself with little to no difficulties. The next two, they're still equations. However, now we have a variable in the denominator, right? This guy. And that can sometimes get kind of messy when we have that variable in the denominator. So I'm going to try to show you a few ways we could work around that. Let's see here. So let's start by drawing this line. And then again, just like the last problem, I have this 3 divided by x and a plus 10. Right? And so just like the last problem, I'm going to go ahead and try to get rid of that 10, and I'll do that by subtracting 10, right? Because you always do the opposite of whatever the operation is. So the opposite of addition is subtraction. That leaves me with 7 minus 10 is negative 3, and that equals, I just have 3 divided by x over here. And this is the part that's tricky, is that usually our x is in the numerator, right? It's in the top of the fraction. If we looked at the previous problem, that h was in the numerator, so we just multiplied by whatever the denominator was. Well, now I have x in the denominator, so I'm going to do a similar thing, and I want to get that number out of the denominator. So I'm going to go ahead and multiply each side by x times x, right? Because I don't like when my x is in the denominator. I really try to get rid of fractions whenever I can, right? So the opposite of dividing by x is multiplying by x to both sides. And so then this leaves me with, on the left side over here, x times negative 3 is just negative 3x. And that equals, on the right side, I'm multiplying by x and I'm dividing by x. So these two reduce. They cancel. And that leaves me with just 3. Okay. This looks like a relatively simple equation I think we could all solve. I'm just going to divide by that number in front of x, right? Because this is multiplication right here. So always just do the opposite of multiplication, which in this case is division. When I divide by negative 3, I see that x equals 3 divided by negative 3 is negative 1. X is completely alone, so I know I'm done with the problem. Let's try one last one. This one's a little more tricky. Maybe you guys could pause the video here for a second and try this one on your own. Okay, let's go ahead and get started. Let's see. So this one, I have a 6 divided by y plus 2, and that equals 6 minus 2 divided by y. This looks very, very messy. I see I have y's on both sides of the equations, and I have constants, the 2 and the 6, on both sides as well. Right? So what I'm trying to do is I want to get all of my y's on one side. Now, it doesn't really matter which side that is, but usually we move all of our y's, or whatever variable we're working with, we move them to the left side, right over here somewhere. So what I'm going to do here is I'm going to try to get this minus 2y, this minus 2 over y. I'm going to try to move this to the left side. So I have a minus 2 divided by y. So I got to do, what's the opposite of subtraction? Well, I'm going to add 2 over y to both sides. Oops, sorry. 2 over y. Okay. So then on the left side over here, this does look pretty messy, this 6 divided by y plus 2 over y. But really, you just got to remember, 6 over y plus 2 over y. Well, if you recall from earlier, whenever you're adding or subtracting fractions, you just need the common denominator, right? You need the bottom of the fractions to be the exact same. Well, in this case, both of my denominators are just y, so I already have my common denominator. So really, I just need to do 6 plus 2. And 6 plus 2 is just 8. And that's still over y. And then I still have my plus 2, and that equals just 6. So now I have all my y's over here. So let's try to get this plus 2 to the other side. What's the opposite of addition? Well, it's subtraction. Let's subtract 2. So then I get 8 over y equals 6 minus 2 is 4. I have 2 more steps here. So this problem looks pretty similar to the last one, right? Remember, usually we multiply by whatever's in the denominator. So here, I'm going to go ahead and multiply by y, because I want to get that y out of the denominator. So let's multiply y to both sides. When I do that, on the left side, I'm multiplying by y and I'm dividing by y. So these two y's reduce, which leaves me with just 8. And that equals 4 times y is just 4y. I got one more step here to get rid of that number in front of y. Right now this is multiplication, so I need to do the opposite of multiplication and divide by 4. When I divide by 4 to both sides, I see that y equals 8 divided by 4 is just 2.